Today our topic will be polyconf, which is polynomial confidence. So poly came from polynomial and conf came from confidence. So as always, why we do care, why we choose today to explain polyconfidence or what this function will do for me. Okay, so it's a cousin of the polyfit. Why it's a cousin of polyfit? Because it has to take from the polyfit two values, P and S, and give polyfit 95% prediction interval of Y, like positive or negative delta, for a new observation. So we're gonna go more in depth of what's its Y, what is delta, why like the polyfit needs 95% predictions. So all of this will be like much more obvious as we go. And also it would give me like a strong correlation between the polyconfidence and the polyfit. So I think there was a very strong episode. Please, you guys have to make sure that you already watch it about the polyfit, but it's all depend on each other. Like it's a chain, like polyconfidence and polyfit and polyval, all of them like serving almost the same reason, so that's why like they always exist together. And also it has a very strong usage in statistics and in finance because it does make a prediction based on the polyfit data. So all the prediction will be just depend on the evidence of the polyfit. So that's why like they are all goes like back and forth together. So before we start, just a reminder, please feel free to go back to MATLAB documentation, as this is where most of the examples inspired from, and MATLAB documentation is right there. Like search wherever you want, search like polyconfidence, anything, because it's very great source, and also it's reference to learn, as in exam or practical. Many instructor will allow you to always use like search documentation. So imagine if you are learning from the documentation and you are in an exam, you can't have like open notes or open source. So without any more introductions, let's just begin. Okay, so our first line will be RNG and then default semicolon. So what's RNG? Basically control random number generator. Like just give me random number generator. I'm telling MATLAB this right now. So I use it for the name. I would use rand, which is random number generator, as I said, and I'm making sure it's on default because it's important in the reproducibility of the results. As like this came from something called Mersenne Twister algorithm with like pseudo, which is also a mathematical concept. Like this very based mathematical concept of how like the programmer program random number generator. But for now, if you wanna random number generator and default, it's gonna give you like random number. Okay, let's specify some ranges. So let's start with x. Let's make it from -5 to 5. So as always, starting from -5 and finishing at 5. This is will be the range of x-axis. And then let's create y. So y x dot power 2 minus 20 multiply by x minus 3 plus 5 multiply by rand. This is good matrix operation, right? Size x semicolon. Okay, let's see it here in the beginning. So right now I have y and I have x. Okay, so what did I do? Beginning of all, I just want to explain this. The dot power, this element-wise exponentiation, okay, and the rest are matrix operation. Rand, we explain rand before, but it just like give you a random number, and the size it gonna give random number for the size of x. So whatever what's the size of x, it's 111. So like one row and 11 columns, it's gonna give you a random number with the same thing, with one row with 11 columns. So also, why did I do this line? What's the purpose of this line? So it's just like some matrix operation which represent noise quadratic. Like it's for plotting purposes, and if you want to test your data under noise, usually you have to do this. So you have always to do y at any form with any numbers, y x square plus bx plus c, and then plus noise. Noise, which is anything you want, which is right now I did the noise in the form of random number with size of x. You can like give any examples for the noise and it will be like the same like result. Okay. Sweet, let's keep going. Now I wanna create p and s. No. Just s as a variable. When make equal to polyfit, we already have our x and y, and then n, which is degree of polynomial fit. I will make this second degree. Okay, so right now what I'm doing, so if I press run, right now I have p and s, this is the p, and I have the struct, which is form of structure, give me degree of freedom, r, the norm, r squared, and the norm. It just exists always in Excel, which like give me a lot of data about my plot, about any figure I want to create. So also, what is p, what is s, and what's the relation with Zeus, with polyfit. We explained polyfit x and y before, so I won't go through this, but I want to explain p and s. So basically, p is a vector of coefficient in descending power. Okay, and s, it just as I said, this is structure that stores information about the polynomial fit. So both p and s, okay, the polyconfidence need to take them from polyfit. That's why I said it's both are related to each other. So I have to create p and s for the polyconfidence to make sure his observation is right. So p and s has to come from the polyfit of x and y data. That's why both are related to each other. I'm explaining all these mathematics expressions because usually if someone will use polyconfidence, he will use it in like mathematical like concept or occasion, usually like mathematical class, or try to apply it on mathematical data. That's why. Okay, now time to estimate 95% prediction intervals by using the polyconfidence. Okay, so let's put here semicolon because we already explained it. Okay, now let's make y fit and delta with the same way, but this time we are using polyconfidence, the hero of the story, polyconfidence interval. So as I said, we want the p that we got from the polyfit, and x, which we already have x, and s, and let's make this alpha .05. Let's press run. So now right now I have the y fit, I have the delta, and alpha it's 0.05. So let's explain this line. So 0.05 alpha would be given, okay, because like as I said, they are all cousins. So polyconfidence has to give 95%, which is like 0.05 is 100% 100% minus 95%. It's gonna leave me with 5%. So this is where it come from my alpha, because I said it's the prediction will be 95% prediction. I want to make this clear. So right now we are estimating 95% prediction intervals by using polyconfidence. So that's why 0.05 came from 100 minus 95 leave me with my 5%. 5% is 0.05 alpha. Okay, so y fit and delta, those two, would represent the polynomial variation from the actual graph. So we're gonna see this, it's gonna be more obvious like when we plot and create a figure, but that's just the variation from the actual, like how far my data will vary or deviate from the actual lines. Okay, so polyconfidence, as I said again, it gives a prediction interval for new observation. Okay, so let's see this graphically. Let's create like figure 1. So let's create plot x, y. Let's make this b plus. Okay, so this would represent my polyfit, because the polyfit has x and y, and I just used my x and y, and the p plus, quick recap, p is just for color, and like instead of making like color and then specify any letter related to the symbols of color, I just make p and plus. This makes the line will be plus, like it's called line symbol, and we explained this also before. And then hold on. So hold on, quick recap also, it makes all plots in the same figure. So if I make one plot, hold on, another plot, it will create the two plots on the same figure. Okay, so we're gonna make plot again, x, y fit, but this time let's make g, and the line symbol will be minus, and this will create polynomial line. Okay, the last one, plot. So I said hold on one time, I don't have to make hold on like each time I write a new plot. So y fit minus delta. Now make it green, the symbol is 2, then x, then y fit plus delta, same thing, r. So quick tip, when it's like I said before, but when it's like this bluish color, this means like I introduced that variable before in my code, and this means I'm like on the right direction, because if this doesn't have the blue one, it's gonna give me an error, and it's gonna give me like unrecognized variable. So if you wanna like check your work as you go, make sure you always have this blue line. Okay, so let's see. Okay, so I have now 3 lines. Okay, so basically this measuring the variation of the polynomial function. So it does have to be deducted from the y fit. That's why like right there in this code, this is like the polynomial fit. That's why like this is the y fit. I subtract one time from delta, and then I add another time from delta to see the variation. So this is a polynomial line, okay? The red line above it, it just means like the addition, and the negative line the subtraction. And all this distance represents the variation between the polynomial line. And those plus signs represent my polyfit. So that's why like here polyfit exists, here polyfit exists, and so on and so on and so on. It's very powerful on the graph, on the figures. That's why like it's always like helpful to represent it on graph. But let's make this more obvious. Let's create a legend. Polynomial data, and then fit, then 95% predictions intervals, and let's make this location. Okay. Best. Okay, this now will make sense more. So this is a polynomial fit, this is a polynomial data, the 95 prediction above and below when I add it or subtract it from delta. So actually that's why it all makes sense when we do graphic, because it's very mathematical, like heavy paced, but it's always obvious like why we are doing all of this when we are seeing on figures.